these states of hormones. So this is an example of the testosterone cycle or pathway in males. And so here's the same loop, but just drawn a little differently. We have the hypothalamus here. It produces something called the gonadotropin releasing hormone that affects the anterior pituitary gland, which then puts out LH, the luteinizing hormone, and that targets the testes in a male, specifically these Leydig cells in the testes. These Leydig cells are not the actual cells that make sperm. These actually are in charge of making testosterone. And as you can guess, testosterone then does this negative feedback loop onto the hypothalamus, which will then regulate the whole system, bring it into homeostasis, bring it nice and stable to a set point based off these integrating centers. Still with me? Same stuff as before. Now, let's say you're a bodybuilder and you decided that you want to cheat. So you inject yourself with a whole bunch of testosterone. So you just add a lot of testosterone. You just inject it into your bloodstream, and it's circling this whole system. What's going to happen? Well, there's more testosterone. This negative feedback increases that much more. This negative feedback increases that much more. This shuts down. This shuts down. And so then what happens is, and this is a common effect seen on a lot of endocrine cells. Oh, sorry. Writing. So yeah, what happens when you add exogenous? Exogenous means you added it from the outside. Endogenous means it was created from the inside. So what happens if you get exogenous testosterone? Well, the testes would shrink. Maybe you've heard this effect on people who use anabolic steroids or testosterone. This is a real thing. This is not a rumor, it's not a myth, it's a real thing. And that's because without this luteinizing hormone, those Leydig cells and those other cells that make sperm, they say, well, they're not in demand anymore. We're not being called upon by the luteinizing hormone to make testosterone. And so to conserve an energy, conserve a metabolism, they're going to reduce in size. They're going to have less Leydig cells. They're going to have less sperm, basically. And literally testes will shrink. And so you'll see that a lot in endocrine systems. Endocrine organs will grow or shrink based on how much they're stimulated. And so this is a real effect, and this is actually a diseased effect. Yes?
So when they stop using exogenous testosterone, does that mean that these will go back to normal?
Yeah, supposedly they will, yes. You can have long-term effects where they won't jump back to 100%, but depends on usage. That's more medical stuff. But theoretically, yes. In the realm of this class, yes. Now, this is my review question for you guys. This is goiter. This is a picture of goiter. Goiters. That's a horrible color to draw. Let me change my color. This is goiter. This is enlarging of the thyroid. And it's usually caused by iron deficiency. And so here on the left is a pathway for the thyroid, right? We have a hypothalamus. It creates what we call thyrotropin releasing hormone, TRH, which will stimulate the anterior pituitary gland, which creates thyroid stimulating hormone, which then stimulates the thyroid gland to make thyroid hormone, and then that, negatively feeds back on the hypothalamus. So goiter is an enlargement of the thyroid gland. So using the feedback loop in the diagram, explain how iodine deficiency creates goiter. And hint, iodine is needed to make thyroid hormone. So think about this, talk to your neighbors. I really mean talk to your neighbors. Take a couple minutes and figure this one out.
that's why they're getting rods are gonna grow. They're getting bigger and bigger.
I guess you could
Make more and more. But
yeah, so I guess then the tissue would grow.
so I'm not setting the stop, the TH to stop it.
No. You have to have your shower. Yeah, iodine
So no TH is being made, it's just TSH is being made, causing the thyroid gland to enlarge.
there'll just be a ton of
Getting TH or TSH. It will never stop again. It's growing and growing, but it's not really, you don't have that necessary component to make what gives it Orders are also made in a different way too, but orders can be made if there's a problem with the TRH.
yeah, that one. Don't say on the bottom of the iodine.
Oh, no way.
Alright, let's bring it back together. Alright, so what do you guys figure out? Who can explain this to me? Yes.
So, when you don't have thyroid hormone,
Mm-hmm.
um,
Well, why don't you have thyroid hormone?
well, you don't have it because if you don't have iodine, then you can't make, maybe you have some thyroid hormone, but not a lot.
Mm-hmm.
Okay.
This goes
So
away.
then TRH and TSH will be created continuously
Mm-hmm.
in excess,
Mm-hmm.
and the thyroid gland, even though it's getting bigger, it won't be able to increasingly inhibit the hypothalamus.
Mm-hmm. Yep, you pretty much explained it. So thyroid hormone can't be made, and so TRH and TSH are going wild. They're just there in the bloodstream in constant amounts, and they're stimulating the thyroid. And remember, when you get stimulation, they're gonna grow in size, right? Same thing like with the shrinking of testes. When there's not much stimulation, they're gonna shrink. The opposite is true. If there's a lot of stimulation, they're gonna grow in size. And so the hypothalamus is like, we really need those thyroid hormones. It's want to keep on coming, and the thyroid hormone can't make it. And so what it does, it grows in size, but despite growing in size, it still can't make the thyroid hormone because of this iodine deficiency. Thyroid hormone needs iodine. This is actually the reason why your government's taken upon itself to add iodine to your salt. That's what iodized salt is. It's just basically salt with iodine. And so, yeah, that's most cases of goiter are due to iodine deficiency. There are some genetic disorders that can create goiter, but yeah, that's that. So that is another example of a disease state. So if you see something like this on an exam, you should be able to ace it, right? All right, good. So we're going to switch gears now. We're done with endocrine system, for better or worse. We're going to move on to the nervous system. Now, half of you guys have started the NeuroSim lab. The other half are going to start right after this lab. And it's going to be kind of an awkward time, because for lab, you're going to have to know what a graded potential is and an action potential is. But I probably won't get to it in this lecture. I might get to a graded potential today. Chances are I'm going to get to action potentials Thursday. So things are not making sense this week in lab. It's okay. Chill. You'll learn it eventually. I'll lecture about it a bit in lab. I'm sure Sarah lectured about it a bit in lab. Has she? Talked about graded potentials at least? Okay, good. So you're not totally out of the loop. But just keep in mind there's going to be this weird disconnect between lab and lecture for a bit. So yeah, nervous system. So nervous system is a big part. It's the other signaling branch of the human body, right? One side is the endocrine system, which we just talked about. The other side is the nervous system. So we're going to spend a lot of time talking about the nervous system. We're going to talk the rest of this lecture about the nervous system,